Everything you thought you knew about the largest carnivorous dinosaur ever to walk the earth? Utter fantasy. 2024 research just obliterated a century of scientific assumptions. Spinosaurus wasn't some land-dwelling super predator terrorizing prehistoric jungles. It was something far stranger, an aquatic nightmare that hunted beneath the surface of ancient rivers. The only dinosaur we know of that lived primarily in water. A skull longer than a human is tall, jaws packed with conical teeth designed for gripping struggling prey, a massive sail rising from its back like a biological billboard. Then it vanished, left behind scattered bones across North Africa and questions deep enough to drown in. What was this creature really? How did it live? Because here's what'll haunt you. More unsettling than discovering a dinosaur that swam is realizing we reconstructed it completely wrong. For decades, multiple times. And the new evidence? We weren't slightly mistaken. We were catastrophically wrong about its posture, its locomotion, even its basic hunting strategy. Spinosaurus might have been the most misunderstood dinosaur in paleontological history. Let's rewrite everything. I'm taking you back 95 million years to when this aquatic titan ruled the waterways of prehistoric Africa. We're uncovering the real Spinosaurus and exposing exactly how scientists got it so spectacularly wrong for so long. Picture a river delta stretching across what's now Morocco. Crocodiles the size of buses, fish larger than great white sharks, pterosaurs with wingspans rivaling small aircraft, and stalking through the murky waters, something evolution had never attempted before. A dinosaur that abandoned land for water. Sounds like science fiction, except it's not. And the proof started with a discovery that would be lost twice before anyone understood what they'd found. 1912. German paleontologist Ernst Stromer was excavating in the Egyptian Sahara when his team unearthed something unprecedented. Enormous vertebrae with elongated spines, some nearly 2 meters tall. A skull fragment revealing a narrow crocodile-like snout, teeth unlike any theropod previously documented. Stromer knew immediately this was something new. He named it Spinosaurus aegyptiacus, Egyptian spine lizard. His 1915 description detailed a carnivore potentially larger than Tyrannosaurus rex. Revolutionary, game-changing, then disaster struck. Stromer's original fossils were stored in Munich's Paleontological Museum. During World War II, Allied bombing raids devastated the city. On April 24, 1944, the museum took a direct hit. Spinosaurus was incinerated. Every bone, every tooth, gone. For decades, all that remained were Stromer's drawings, photographs, and written descriptions. Scientists had to reconstruct this massive predator from sketches and memories. That's like trying to understand a great white shark from a child's crayon drawing. The result? Complete chaos. Without physical specimens, paleontologists made educated guesses. They assumed Spinosaurus was essentially a bigger, sail-backed version of other large theropods, standing upright on 2 powerful legs, walking through forests, hunting like T-Rex, but with a funny-looking spine. This image dominated for half a century. It appeared in textbooks, museums, documentaries. Even Jurassic Park III in 2001 showed Spinosaurus as a bipedal land predator, famously killing a T-Rex in a controversial scene that sparked endless debate. All of it was wrong. The resurrection began in 2008, when Italian paleontologist Cristiano Dal Sasso received a package. Inside were partial Spinosaurus bones smuggled from Morocco. The specimen had passed through fossil dealers and private collectors before reaching scientists, a frustratingly common problem in paleontology. These bones revealed something disturbing. The hind limbs were shorter than expected, much shorter, proportionally smaller than any large theropod on record. This didn't fit the bipedal predator model at all. Then came the breakthrough. In 2014, Nizar Ibrahim led an expedition to the Kem beds in southeastern Morocco. What they found rewrote dinosaur history. A remarkably complete Spinosaurus specimen, the most comprehensive since Stromer's destroyed original. 15 meters long, 7 tons minimum. Hind limbs absurdly short for its body size. Front limbs unusually long and powerful. Dense bones throughout the skeleton, far denser than typical dinosaurs. Ibrahim's team published their findings that September. The conclusion shocked the scientific community. Spinosaurus wasn't built for land at all. Those dense bones? Ballast, like a scuba diver's weight belt. They help the animal sink and stay submerged. The short legs? Useless for efficient walking, but perfect for propulsion in water. The elongated skull with retracted nostrils? Designed for sweeping through murky rivers, snatching fish. Spinosaurus was semi-aquatic, the first dinosaur confirmed to have lived primarily in water. But even this revolutionary reconstruction had problems, major problems. The 2014 model showed Spinosaurus walking on all fours, a quadruped. Other paleontologists immediately pushed back. The evidence was incomplete. The interpretation was contested. Science got messy. Some researchers argued the bones came from multiple individuals, making size estimates unreliable. Others claimed the short legs might have been from a juvenile mixed with adult specimens. The quadrupedal posture faced particular criticism. No other large theropod moved this way. For 6 years, debate raged. Was Spinosaurus really aquatic? Was it quadrupedal? Bipedal? Some unholy combination? 2020 delivered the answer, and it was stranger than anyone imagined. Ibrahim's team returned with new findings. This time, they had something unprecedented, a complete Spinosaurus tail. Previous reconstructions assumed a typical theropod tail, narrow, stiff, used for balance while walking. The actual tail was nothing like that. Spinosaurus possessed a massive paddle-shaped tail. Tall neural spines created a continuous fin-like structure. It looked more like a crocodile's tail than a dinosaur's. Computer modeling showed this tail could generate significant thrust underwater. Before we go deeper into what this changes about everything, if you're the kind of person who finds prehistoric mysteries irresistible, hit subscribe and turn on notifications. What's coming next will make this look tame. because we're about to uncover hunting behaviors that'll make you grateful this thing went extinct. The paddle tail discovery transformed our understanding completely. Spinosaurus wasn't just capable of swimming, it was adapted for pursuit predation in water. This wasn't a dinosaur that occasionally waded through rivers like a grizzly bear fishing for salmon. This was a 15-meter apex predator actively hunting underwater. Think about that. For 180 million years, dinosaurs dominated land while marine reptiles ruled the oceans. The two stayed in their lanes. Spinosaurus broke that boundary. It evolved to invade aquatic ecosystems dominated by giant crocodiles and massive fish. Its hunting strategy becomes clear when you examine the skull. That narrow, elongated snout housed 64 teeth, not serrated blades like T-Rex used for tearing flesh. Conical spikes perfect for gripping slippery, struggling prey. The teeth interlocked when the jaw closed, creating an inescapable cage. Pressure sensors likely lined the snout. Similar to modern crocodilians, Spinosaurus could detect movement in murky water without seeing its prey. It hunted by feel. The diet consisted primarily of massive fish. We know because Spinosaurus fossils appear alongside Onchopristis, a sawfish reaching 8 meters long. Mawsonia, a coelacanth relative exceeding 4 meters. These weren't minnows, these were monsters. Tooth marks on fish fossils match Spinosaurus dentition. Stomach contents from related spinosaurids confirm fish-heavy diets. The picture emerges of a patient underwater stalker, drifting through prehistoric rivers, snapping up prey in powerful jaws. But the sail. What about that ridiculous sail? Rising nearly 2 meters tall, supported by elongated neural spines, the sail remains Spinosaurus's most distinctive feature, and scientists still argue about its purpose. Thermoregulation was the classic explanation. A giant sail filled with blood vessels could absorb heat in morning sun, then release it during hot afternoons, like a biological radiator. This made sense for a land animal, but Spinosaurus was aquatic. Water absorbs heat far more efficiently than air. A thermoregulatory sail would be pointless, possibly even counterproductive, in aquatic environments. Display seems more likely. The sail would have been visible above water while the animal swam. A massive advertisement saying, "I'm enormous, don't mess with me." Or alternatively, "I'm an impressive mate, choose me." Some researchers propose the sail stored fat reserves, like a camel's hump, energy storage for lean seasons. This remains speculative but intriguing. The honest answer? We don't know. After a century of study, Spinosaurus's most obvious feature remains its greatest mystery. Here's where it gets truly disturbing. Spinosaurus wasn't alone. The chem ecosystem that Spinosaurus inhabited was absolutely stacked with predators. Carcharodontosaurus, a massive theropod rivaling T-Rex in size, stalked the same territory. Deltadromeus, a long-legged, fast-running predator, hunted smaller prey. Multiple large crocodilians patrolled the waterways. How did so many apex predators coexist? Resource partitioning. They weren't competing for the same food. Carcharodontosaurus hunted land animals, large sauropods, ornithopods, typical dinosaur fare. Deltadromeus pursued smaller, faster prey. Spinosaurus claimed the water. Its unique adaptations gave it access to an entire food web that other dinosaurs couldn't touch. It essentially invented a new ecological niche, aquatic dinosaur predator. This niche partitioning explains how the chem beds preserve such an absurd concentration of carnivores. They weren't all hunting the same things. They divided up the ecosystem. But this specialization came with a cost. 95 million years ago, Spinosaurus vanished, not gradually, abruptly. The fossil record shows Spinosaurids disappearing from Africa and South America within a relatively narrow time frame. Why? Environmental change. The river systems Spinosaurus depended on weren't permanent. Sea levels fluctuated throughout the Cretaceous. Those massive deltas and waterways transformed, some dried up, others were flooded by marine incursions. A dinosaur that evolved specifically for freshwater river ecosystems had nowhere to go when those ecosystems collapsed. Spinosaurus was too specialized. The very adaptations that made it successful became liabilities. Carcharodontosaurus could theoretically move to different hunting grounds. Spinosaurus couldn't. Its dense bones, paddle tail, and fish-catching jaws were useless on land. Evolution had locked it into a specific lifestyle. When that lifestyle disappeared, so did Spinosaurus. There's a modern parallel. Giant pandas are so specialized for bamboo that habitat loss threatens their entire species. Koalas depend so heavily on eucalyptus that Australian wildfires devastate their populations. Specialization provides advantages until conditions change. Spinosaurus was the Cretaceous version of this trap, perfectly adapted, then perfectly extinct. So what's the final picture? After a century of confusion, destroyed specimens, smuggled fossils, and scientific revolution, what was Spinosaurus really? A 15-meter aquatic predator, dense bones for ballast, a paddle tail for propulsion, conical teeth for gripping fish, pressure-sensitive snout for detecting prey in murky water, short hind limbs, powerful forelimbs, that massive, mysterious sail, not a land-dwelling super predator, not a bipedal T-Rex competitor, not the creature from Jurassic Park III, something far stranger, something evolution attempted exactly once. A dinosaur that invaded the water and dominated for millions of years before vanishing when its world changed. And here's the unsettling truth we're left with. We still don't have a complete Spinosaurus skeleton. Every reconstruction is partially speculation. Every model contains educated guesses. The original fossils were destroyed by bombs. Modern specimens remain fragmentary. We've been wrong about this animal multiple times. The 1915 version was wrong, the 1990s version was wrong, the 2014 version was incomplete. Even the 2020 reconstruction might contain errors we haven't discovered yet. Each new fossil rewrites the story. Each excavation reveals something unexpected. Spinosaurus keeps surprising us, like it's protecting its secrets across 95 million years. There's just one way to know for certain what Spinosaurus truly was, and despite a century of searching, we've still never found a complete skeleton. So until then, aquatic nightmare with a mysterious sail it is. The rivers are gone, the deltas are dust. Spinosaurus vanished into extinction alongside the ecosystem it evolved to dominate. But somewhere beneath the Moroccan sands, more bones wait, more teeth, more vertebrae, more secrets. And the next discovery might change everything again. The anatomy reveals even more disturbing adaptations when you examine it closely. Those conical teeth weren't randomly placed. The largest teeth sat at the front of the snout, creating a terminal rosette, a bulbous cluster designed for the initial strike. When Spinosaurus lunged at prey, these front teeth made first contact, gripping, piercing, refusing to release. Behind them, smaller teeth lined the jaw in a precise gradient, each tooth angled slightly backward. Once prey entered that mouth, escape became geometrically impossible. Every struggle drove the victim deeper into the trap. The nostrils tell another story. Unlike typical theropods with forward-facing nostrils, Spinosaurus had retracted nasal openings positioned high on the skull, almost between the eyes. This placement allowed the animal to breathe while nearly submerged, only the top of its head breaking the surface. Imagine a 15-meter predator drifting through prehistoric rivers, invisible except for that ridge of skull. Eyes scanning above, pressure sensors scanning below, waiting. The forelimbs deserve attention too. Spinosaurus possessed unusually large hooked claws on its hands, each claw curved like a meat hook, powerful forearm muscles attached to reinforced bones. These weren't delicate manipulators, they were weapons. Some researchers believe Spinosaurus used these claws to pin struggling fish against river bottoms. Others suggest they helped the animal anchor itself against strong currents while feeding. Either way, the message is clear. Those forelimbs were built for violence and control. The skeleton tells a survival story too. One Moroccan specimen shows evidence of healed injuries, bite marks on vertebrae, tooth punctures through bone that subsequently scarred over. This individual survived attacks that would have killed most animals. The attacker, probably another Spinosaurus. Intraspecific combat, territorial disputes, competition for prime hunting grounds. These weren't peaceful giants, they fought each other with those massive claws and crushing jaws. The fossil record preserves their battles. Another specimen reveals something equally brutal. A Spinosaurus vertebra with an embedded tooth, not its own. The tooth belonged to a carcharodontosaurid. A massive land predator had attacked this Spinosaurus, likely while it was vulnerable on a riverbank. The Spinosaurus survived, carried that tooth fragment in its spine, healed around it, kept hunting. Picture that moment, a 15-meter aquatic predator hauling itself onto a sandbar, perhaps to rest or thermoregulate. A carcharodontosaurus, equally massive, built for land, sees opportunity, attacks. Teeth sink into flesh and bone, but Spinosaurus doesn't die. It fights, maybe retreats to water where its attacker can't follow, survives with a permanent souvenir embedded in its skeleton. These weren't gentle times. These weren't gentle animals. The brain case adds another dimension. CT scans of Spinosaurid skulls reveal enlarged regions associated with detecting movement and processing sensory information from the snout. The olfactory bulbs, smell centers, were relatively small. Vision processing was moderate, but the areas connected to those pressure-sensing snout receptors, massive. Spinosaurus navigated its world primarily through touch, through water pressure, through vibrations traveling along its submerged skull. A blind Spinosaurus could probably still hunt effectively. It had evolved beyond needing to see its prey. This sensory adaptation mirrors modern crocodilians so closely that some researchers call it convergent evolution at its most extreme. Two completely unrelated lineages, dinosaurs and crocodilians, independently evolved nearly identical hunting systems for the same environment. Evolution kept arriving at the same solution: murky river predator, pressure-sensing snout, conical teeth, patient ambush strategy. The blueprint worked so well that nature invented it twice. The growth patterns reveal lifespan details. Bone histology, microscopic analysis of growth rings, suggests Spinosaurus reached maturity relatively slowly, perhaps 20 to 25 years to full adult size. This extended growth period meant juveniles spent decades vulnerable, too small to dominate, too specialized to hunt elsewhere. Juvenile mortality must have been catastrophic. Those same crocodilians that adults competed with would have readily consumed young Spinosaurus. The waters that adults ruled were death traps for their offspring. This explains why Spinosaurid fossils skew heavily toward adults. Juveniles simply didn't survive in numbers sufficient to leave abundant fossil records. Natural selection culled them relentlessly before they could reach the size where water became safety rather than danger. The extinction story deserves expansion too. When those river systems collapsed, Spinosaurus didn't just lose hunting grounds, it lost everything. Breeding sites, nursery areas, migration corridors. The entire infrastructure of Spinosaurid existence vanished over geological timescales that felt instantaneous to evolution. Some researchers propose a cascading collapse. First, the rivers changed, becoming too shallow, too seasonal, too salty for marine intrusion. Then the giant fish populations crashed without stable habitat. Then Spinosaurus, dependent on those fish, followed. The ecosystem unraveled from the bottom up. By the time Spinosaurus disappeared from the fossil record, the world it evolved for had already ceased to exist. The extinction wasn't a dramatic event, it was an erasure, silent, complete, inevitable. Modern paleontology keeps revealing surprises. As recently as 2023, new spinosaurid material from the Isle of Wight suggested these animals were more diverse than previously recognized, different species occupying different niches, some more aquatic, some less. Spinosaurus aegyptiacus may have been the most extreme example, the most committed to aquatic life, but it wasn't alone in experimenting with water. An entire family of dinosaurs repeatedly evolved toward rivers and coastlines, and they all vanished, every single lineage. Whatever advantages aquatic adaptation provided, it ultimately failed. Land-dwelling theropods survived the mid-Cretaceous upheavals that eliminated spinosaurids. The experiment ended. So we returned to where we started. A creature reconstructed wrong for decades, destroyed by bombs, resurrected from fragments, still hiding secrets in scattered bones. Spinosaurus represents paleontology at its most humbling. A reminder that fossils are incomplete stories, that scientific consensus can be completely catastrophically wrong, that the next discovery, tomorrow, next year, next decade, might demolish everything we currently believe. The rivers are gone, the deltas are dust, the chem beds bake under Moroccan sun, surrendering bones millimeter by millimeter to erosion and time. Somewhere in that ancient rock, a complete Spinosaurus skeleton might wait, undisturbed for 95 million years. Every season, paleontologists return. They dig carefully through sediment that once lined riverbanks where giants hunted. They find teeth, vertebrae, fragments. Never enough, never complete. Spinosaurus vanished into extinction alongside the ecosystem it evolved to dominate, but its mystery refuses to die. Each year brings new questions, new debates, new reconstructions, and the next fossil might change everything, again.